Hi, welcome to the session by RouteFabric, and in today's session we're going to be going over the Java basics. Alright, so before we get started, I just want to preface that this is going to be the fundamentals of Java, so you don't need any programming experience whatsoever to understand what's going on. And so that means keep in mind that if you do have programming experience, a lot of this stuff might be obvious to you, but I just want to make sure I cover all the bases here and that we all have a good understanding of the fundamentals of the Java programming language. So the plan is, so first we're going to discuss the fundamentals. This is going to be variables, data types, functions, etc. And then we're going to experiment and practice in our IDE for a bit so we get a feel for it, and we're going to try some stuff out. And then we're going to write a simple hello world Java program as our first program. All right, so variables and data types. So data can be stored in our Java program in variables. So these aren't unlike mathematical variables that we've been using for years. So basically, some symbol represents some underlying data. So you'll see an equation like y equals x squared, and x represents some number. So let's say it's 10 equals x squared. Then x is square root of 10, that kind of thing. So variables can store a lot of different data from simple types like integers, whole numbers, 1, 2, 3, or negative numbers as well. And they can also store very complex types like large objects. And we're going to get more into objects as we move along later in Java. Just know that we're still going to be using some objects that the Java language provides for us, and we don't have to understand, exactly how they work to use them, but we will eventually get to object-oriented programming and making our own classes and objects and that kind of thing. So in Java, each variable must have a type. So we'll go over some types in the next slide, but types are very heavily enforced in Java. Basically, in Java, we do not have access to the underlying memory of a variable like we do in some other languages. For example, C and C++, we can access the memory of a variable. So that means that even though there are types in place in C and C++, you can sometimes get around that um, by just directly accessing the memory. In Java, we can't do this. We don't have access to the memory directly. And in Java, each variable must have a type, so types are pretty strictly enforced in Java. So in our code, in order to use a variable, we must first declare it. So the reason we have to do this is we're basically telling the JVM, hey, this symbol, this word that we're going to use exists. It's something that is real. If you were just to type in, like, you're typing your program and you said, oh, hello equals 10, your your program doesn't know what that means. It's going to say, hello, what is that? I've never seen that before. So we have to first declare a variable. So you're telling your program, hey, this exists. So if I change it or use it later on, it's not something unknown. So once a variable is declared, it can then be initialized or set to a starting value. So oftentimes this is done at the same time as declaration, but this is not always the case. There's a lot of situations where you'd want to declare it and then not necessarily set it to a value until later on. So any initialization and changing of a variable is done with the assignment operator, which is equal sign. So a lot of people get confused when they first see an assignment operator in a programming language because they get it conflated with, in math, an equal sign. So in a programming language like Java, equal sign doesn't mean equivalence. There's actually a different operator for that. It doesn't mean equivalence, it means assignment. So whenever you see a variable and then equals some other value, what that actually means is, hey, take this data and assign it to this variable. Put it in that variable. So just so we are all on the same page about the assignment operator. Note, it is good practice and always recommended to name your variables relevant names. So let's say, for example, you're writing a program and you need to get someone's age. You'd want to name your variable age or person age, something like that. You wouldn't want to call it number or x. And this also happens all the time with people who are new to programming because, generally in math, you call variables very concise names because you use them a lot, so you want them to have concise names like X, Y, Z, W. But when you're programming, generally you do not want to use names like that because the problem is it becomes unclear what your variable is actually representing. So then if you go back later, maybe a few weeks later or even just the next day and you're looking at your code, if you have a lot of variables and they're all named irrelevant things, it's going to be very difficult to tell exactly what's going on. This is also useful if you're working on a group project or that kind of thing. You want everyone to be able to tell, okay, well, int age is an age, you know what I mean? So then it's very clear because you could have a lot of different variables of the same type. So if you have, int x, int y, int z, int w, you're going to be looking at this and you're not going to be able to tell which goes to what. Okay, is x the height or is x the age? That kind of thing. Also note, there are some restrictions for variable names. So for example, we cannot name a variable a number. And this is obviously very confusing and ambiguous to both us and the Java virtual machine. So let's say we named our variable 1, like the actual number 1, not typed out 1, but like 1. We said, int 1 equals 5. Okay, well, that would be very confusing because then what happens if we were to use the number 1 later in our code? Are we talking about the variable or are we talking about the number? Because if we're talking about the variable, that number is actually 5. So it becomes very confusing. And so the JVM doesn't allow this, Java doesn't allow this at all. It'll break your code. So just keep in mind if you ever get an error with like a variable or anything like that, make sure you're naming it something that is reasonable. So usually words, you want to name it words, never symbols or that kind of thing. All right. So data types. So we said every single variable must have a data type. So what are these? So data types tell Java what kind of data your variable will be storing. So this is very important because different types of data take up different amounts of space and they're written in a different way. So for example, an integer and a floating point number are stored very, very differently in your computer's memory, even though they could be the same exact number to us. So, we see the number 4, an integer value 4, versus the floating point value 4.0. To us, those are exactly the same, but in reality, to our computer, these are stored very differently because floating point calculations and floating point storage is just very, very differently as opposed to integer types. So, in Java, we have something called primitive data types. These are the absolute basic data types, and these are guaranteed to be included in the Java language. So these are not objects. These aren't anything special. These are the very basics. These are going to be predefined for us. So like I said, these are the most basic of data types. So this includes, there's some more too, but we have int, char, byte, float, and boolean. So notice that these are all lowercase. This is actually kind of important. Convention is that primitive types are lowercase. So in Java, generally, when you're using a more advanced type, like an object, something derived from a class, it's going to be capital. So for example, we're going to get into it in a bit for strings, for example. Those are always going to be capital because those are not a primitive type. So, like I said, we also have non-primitive types. So these are called reference types as well, and they're called this because they reference an object. So they refer to some object in the language or some object that we can define ourselves once we get to that later on. So, like I said previously, we're going to get fully in depth with objects and object-oriented programming later, but for right now, we can still use some objects provided to us without fully understanding how objects work or what goes into them. So one common example is we will be using strings all the time. Strings are very common to use, and we won't necessarily know what goes into the string class or how it's formatted, how the memory is allocated, that kind of thing. We don't need to worry about all that. So strings are basically, they hold a sequence of characters. So this can be like someone's name or street address. So for example, the string Lucas, that's a string because we have multiple characters. We have an L, we have a U, then a C, then an A, then an S. So that's going to be of a string type. And these are very common to be used. All right, so this is just a little bit more in-depth overview of the primitive types and also string is on here. So int, this refers to an integer value. So this is any whole number. So you can do -1, 0, 1 million, anything like that. So the int type can store numbers a little north of 2 billion, and that goes both ways. So positive 2 billion and negative 2 billion. So these are really general purpose. You're going to be using integers a lot for holding numbers. You also have the char type. So these hold a single character, such as like a lowercase a or a capital L. And notice I'm saying lowercase and capital because there is a difference. These are stored differently. So you need to keep that in mind if you're doing, say, a comparison or something like that. Lowercase a is not the same as capital A. There are different characters. So also notes that these are essentially specialized and smaller integer types. So an integer can hold, a little north of 2 billion. A character is really also just a number. The language stores your characters as numbers for efficiency's sake. And so your character really goes from 0 to 255 is how many characters there really are. But when we use a character, we are actually most of the time going to be using the character itself, not a number. Um, but that is something to keep in mind because sometimes you'll be wondering, why is this interpreted as a number? Why did I get this behavior? It's because characters are essentially specialized integers. So that is something to keep in mind. And also note, these must be specified with single quotes. So whenever we want to do a character, we want to initialize it or declare it. Well, not declare it, but we want to initialize it or assign it a value. We want to use single quotes for this. We also have a float as another type, and these hold a floating point number. So this would be like 3.14, 1.99. So these are useful for if you're doing complex calculations that require floating points, or if you have like money, that kind of thing. These are when they're used for. So this is something to keep in mind. This is kind of convention and best practices. Generally, these are only used when necessary. So don't use these in place of an integer. A lot of people, when they first start, will think, oh, well, int is a number, and float is also a number, but float has more power, right? Because you can put decimals with it, and you can't do that with an integer. So why wouldn't you just use a float all the time? Even when you only need an integer, wouldn't it just make more sense to use a float? Because then later on you can add, if you do need a decimal, you can just add it on there and you don't have to like change the type or anything like that. And generally, no, because floating points are stored differently than integers, and integer calculations are much more efficient for a computer to execute. So only use a float if you need it. So, if you're doing money or something like that, use a float. But if you're representing someone's age or, something like that, how much of something you have, let's say how many cakes you have or something like that, use an integer. That makes the most sense. So Boolean. Booleans are another primitive type, and they only hold two values, either true or false. So we're not going to use these starting off just yet, but these are going to be essential for when we get to logic and Boolean algebra. Once we get to decisions, these are going to be a big deal, and you're going to want to use Booleans for this. So strings, we already talked about them a little bit as well. So these are objects, and they hold an array or a sequence um, of characters. So we're going to want to use this anytime we want to store like a name, a street address, anything like that, something that's kind of abstract, you can store in a string. You can also store single characters in a string if you want. So if you wanted a string with just A in it, you could do that. Also keep in mind you can have numbers and stuff in a string. Strings are just a little bit more abstract. So when we see an integer, we know an integer is a number. But when we see a number within quotes for a string, that's just interpreted as a string. So the computer isn't going to deduce exactly what that is. It's not going to say, is this a number? Is this an actual name? The computer's not going to do that. So these are a little bit more abstract to think about. And it's important to note these are denoted with double quotes. So anytime we initialize a character, we use single quotes. Anytime we use a string, we want to use double quotes. And this is important because if we don't use double quotes, the programming language isn't going to know it's a string and we're going to get errors. All right, so functions. So we talked about data, and that's cool. We can represent data. We can represent numbers, names, that kind of thing, but so what? Data on its own is not particularly useful. It's neat if we want to store things, but we also want to be able to do things with our data. So in addition to data, programs have functions. So functions can do things, and this can include data, or they can also do things without data. Um, so with functions, we can manipulate data, we can move our data, we can create new data, we can perform some tasks such as outputting something to the screen. We can really do anything with a function. So sometimes we'll have a function and we'll take some data and we'll change it. Let's say we make a function to change a character from lowercase to uppercase. We can do that. So we can take a character in and then we can do something to it and make it uppercase and send it back out, that kind of thing. Or we can have a function where we don't do anything with data at all. So let's say we take data from something and then we just put it somewhere else. So, we have a function, we take in some data, and then we say, output this to the screen so we can see this data. Or we say, okay, write it out to this file. Or let's say we even have a library or something that allows us to connect to some database on the internet, and we say, okay, take this data and upload it to this internet address or something like that. Or you can even have functions that don't take in data and they don't return any data. So you have a function, let's say you just want a function that just says hello. You can just have a function, you can just call it and it just says hello. That's all it does. It doesn't create any new data or anything like that. So it is said that all computer programs ever created can be boiled down to just algorithms, which is essentially functions and data structures. So that's pretty crazy to think about, that all the complex software that we use every day um, can just be boiled down to a bunch of different functions and a bunch of different data structures. So this PowerPoint, the entire Windows operating system, that kind of thing, it can all just be scaled down to just being a bunch of algorithms and data structures. So the more we understand about how functions work and how algorithms work, and the more we understand about using data structures and creating our own data structures, the more powerful of programs we're going to be able to create. And in reality, we have already dealt with functions all the time. So think of the function x squared, y equals x squared. Well, this is a mathematical function, a little bit different from a function we use in programming, but it's actually pretty similar. So we input some data represented by x, and then we output some new data, which is x times x. So this would be an example of a function that takes in some data and also returns some data. So in Java and in really most programming languages, we already have some provided functions we can use. So the Java language comes with a set of functions that you can choose to use if you want to, and these can do some basic things for you, and we will be using some of these. We'll also, of course, be defining our own functions and using those, but for the basics, you want to use the functions that Java already supplies to, so we'll go over those. All right, so let's go ahead and jump into some code and test out our new knowledge. So I just have Eclipse open here. That's the IDE I'm going to be using, but any IDE will be just fine. So of course, this is going to be different depending on what IDE you use, but in general, you're going to want to create a new project. So we'll just create a new Java project. We'll just name this anything. So I'll just name this something like uh, RouteFabric. I think that'll be fine. And then we don't really need to worry about any of this. I will be checking this window. Use project folder as root for sources and class files. This, I think, just makes a little bit more sense to me. All right, and we'll click next, and this is fine. All right, so if we open up our new project, this is where we're going to be creating all our programs and that kind of thing. So in our project, we can have multiple programs, and the way Java kind of has it set up is you can have multiple what they're called classes, and we'll get into depth with what classes are later, but you can have multiple classes either in different files or in the same files, and then you can include these all together into one program, one executable. So that's really awesome. That makes our lives way easier. So for our project, we're just going to create a new class. Well, actually, yes, I think that's fine. That'll be fine. We'll get into packages later. We haven't really talked about packages. I'll mention them a little bit here. Basically, a package is kind of an organizational tool in Java. So it's if you've used something like C++, it's like a namespace. So basically what that means is it kind of groups together um, all the things you make or someone else makes. It puts them all into the same uh, package for us to deal with, so it becomes clear what's coming from where and that kind of thing. So when you make a program in Java, everything must be in a class. You cannot create any functions or anything outside of a class. So that means we have to create a new Java class. So let's create a new class, and that'll be fine. and then we can name this class whatever we want. So we'll just call this like Java Basics. There are restrictions to class names as well, but it'll tell you if you mess up a class name. And then this part is kind of important. It says which method stubs would you like to create, and we're just going to check public static void main. So I'll talk about what this is in a second, but we already kind of have some idea about what this is because we talked about functions. So I'll show you real quick. So this is actually a function. So main is a function. So right off the bat, we created our class and we've already set up a function. We could have written this out ourselves, or we just got basically the IDE to write it out for us by checking that box. But so main is a special function, and basically what it is when your Java program runs, it needs to know a place to start. So it's not just going to choose some random function in your code. So let's say you have, a bunch of different functions. You have like 10 different functions. Your program isn't just going to go eeny, meeny, miny, mo and choose one to start. It's going to look for a special function called main. And main is going to be the starting point for every program. So it's going to look for main, and then once it hits main, it's going to execute that. So from main, you can call other functions to do things, or you can do stuff directly in main if you want, whatever you want to do. So every time you write a function, you're going to need a main method. So if you don't have a main, your function isn't going to run. Your program's going to run, it's going to say, there's no main, so I'm not going to do anything. So we just generated it with the IDE, so it did it for us. But like I said, we could have done it ourselves. We'll just delete this little comment here. So you may have noticed that I just referred to it as a method. So methods and functions for most purposes are really the same thing, especially in Java. Really, a method is just a special word for a function that exists within a class. So anytime a function is within a class, some people like to refer to this as a method. So as I just stated a little bit ago, everything in Java must be inside a class. We can't write functions outside of a class. So therefore, every function in Java is also a method. So you'll see a lot of people call them methods. You see a lot of people call them functions. Really doesn't matter. They're in Java, you can interchange them, and no one's going to get too upset about the semantics. Really, method is a little bit more accurate because it describes a type of function that pertains to a class. So method is a little bit more accurate way of saying it, but they're both really the same thing. So right off the bat here, we can get kind of a feel for some of the syntax up here. So you'll see at the very top, we have package RouteFabric. So when we created this, it created a package for us actually, and just called it the same thing as our project. So like I said, a package is basically just an organizational tool to put all the stuff you create into one place. So this means, if you're using someone else's code or something, it's going to be within its own package. If you're using, your own code, or you're writing your own code, you want to put it within its own package just for organizational reasons, just to make sure everything's clear. We'll get into packages later. There's a little bit more to it than that, especially regarding access. But for now, just know that a package is just basically a form of organization. And then here we have a class. Like I said, everything has to be within a class. So this class is just called the same thing as what we named it. In Java, this always has to be true. So we named this Java Basics like class, you know what I mean? So this has to be called Java Basics. So when you create a class in its own file, that has to be true. You can't name it whatever you want. It has to be named after what the class is actually named. And then you'll also notice these parentheses. So these mark what is called scope. So when we have parentheses, what we're saying is this is how far this thing extends. So I like to put my parentheses on their own line. By default, Eclipse doesn't do this, but you can set it to do that by default. But I can just put this on its own line. And basically what this is showing is that we have public class Java Basic. So this is our class that it created for us. And we have an open curly brace and a closed curly brace here. So what we're saying is this class extends this far in our code. So anything that we write within these curly braces pertains to this class, is what we're saying. So this is a syntax kind of thing. So this is how Java knows, hey, this is where your class starts, this is where your class ends, this is where your function starts, this is where your function ends. So that's why parentheses exist. So basically all this is saying is, hey, our class starts here and it ends here. If you forget a parentheses, you'll run into some errors because your program's going to be going along and it's going to say, hey, where does this end? It's going to run into an error. And then whenever you have functions as well, you also want to put parentheses around your functions. So this is telling you, hey, this is main, this is where main starts, this is where main ends. We can also minimize functions if we, write a function. This is just a visual thing. Just makes it easier for us to see, if we have a ton of functions, we can minimize the ones we're not working on right now, that kind of thing. All right, so we have basically everything we need to set up. So let's actually do something now. Let's create a variable. So like I said, when we create a variable, we need to specify a data type. So we'll just start off with one of the most commonly used ones that we talked about, an integer. So first we're going to need to declare that we're making an integer. So we just specify that with int, and you'll notice here it changes a different color, and then we'll give it a name. So I'll just call this, let's do year. So I'll call this year. All right, perfect. And as you can see there, it created our integer and it declared it. So there's no error here. We do get a little warning. Java will give you warnings if you declare a variable and then you never use it. And the reason it does this is so you don't waste space, because a lot of people will, they'll end up creating a variable and they'll forget that they made it and they'll make a new variable to store basically the same data. And then you're just wasting space because you declared both these variables and you don't need them. So if you don't use a variable, it'll tell you, hey, this variable isn't used. All right, then we can assign our year a value. So we'll just say year equals the assignment operator, and we'll do 2020. So we're saying we have an integer here, year, and then we're assigning it the value 2020, 2020. So you'll also notice that after each line, I put a semicolon. So why do we do this? The reason Java has semicolons after each statement is so that the JVM can understand, hey, I'm done making the statement. And the cool thing about this is, you have some languages like, say, Python doesn't require a semicolon after a statement. So a lot of people will say, well, then why does Java require it? Why is this necessary? Why am I wasting my time putting all these semicolons? Well, because this gives us flexibility. So like I said, I could put year on its own line like that, or I could go right back up here, and I can put year on the same line, and this works too. And the reason this works is because we have a semicolon. So the program knows, hey, I'm done. Okay, hey, I'm done. So it's not relying on a new line like some other languages do. All right, so if we were to run our program, so we'll just save it right now. So we'll just save this, and we can press this little start button to run. We run our program, and you'll notice it ran. It'll show us right at the bottom. It says terminated. So this program ran, and then it finished. So we did do something in this program. We ran our program. We created a new integer and then we assigned it the value 2020. But then that's it. Our program didn't do anything else. So like I kind of touched on earlier, whenever you're writing in a programming language like Java, it's not going to assume anything for you. It's not going to say, oh, like it wants you to do this, so it's going to do that for you. No, Java doesn't like to do stuff like that for you. So we created an integer, but we never specified, oh, output it to the screen so we can see it. We didn't specify that. So all it did was created this integer, assigned it a value, and the program ended. So we should be a little bit more specific if we actually want to see our integer here. So this is where the built-in Java functions come into play. So we can do something like system.out.printf, and then we'll do %d, and then over here we'll put year. All right, so this might seem very confusing, so I'll go over what this means exactly. So luckily we kind of understood some of the syntax already. So we see system. So we know system here is an object because it starts with a capital letter. So convention, we can tell this is an object. So when we say system, what we're calling to is the actual system itself. So we're saying, hey, JVM, go to the system and then do this. So just saying system isn't specific enough. We need to say system, okay, what? Where do we want to go? So we're doing out. So what this is telling us is output. So we're saying, okay, go to the system and then output something. So we're saying system.output out, and we have to specify exactly what we want to do. So there's a lot of different functions we could use here. There's just plain old print, or there's sprint, that kind of stuff. We used a function called printf. So this is a function that comes built into Java, and this is going to be for printing, in this case, to the screen, to system.out, which is just going to be our console down here that we saw earlier. This is where it's going to print. And the F here is short for format. So print format. So when we're printing with printf, we want to print with formatting enabled. So this %d here, this is a format specifier. So whenever we're printing with printf, or we're using something like string.format, we want to use percentages for formatting. So when we put a %, we're essentially telling printf or string.format, any formatting kind of function in Java, we're telling it, hey, we want to format this a special way. So when we say %d, it's not actually going to print out %d. You know, that'd be weird. We would run our program and then it would just say %d. Well, what we're actually saying when we put in %d is we're saying, replace this with something else. Change the formatting a little bit. So there's a lot of different formatting specifiers, and we'll go over these later. So we can use D for integers, we can use F for floats, we can use C for characters, we can use S for strings, that kind of thing. But so we're saying %d, so what we're saying is this is actually a formatting specifier for an integer. So replace this with an integer. So then in our second part of the function, the second parameter this is called, we need to supply it some integer. So we're saying year here. So we're going to say, okay, go to the system, output, print something, and then when you print something, replace this %d with an integer, and the integer we want to replace it with is year that we specified up here, and then that's it. So now if we save this and we run it, we'll see that we get 2020. So what we just did here is we created a variable, we initialized it to some value, and then we called a function to do something with that data. So in this case, we just printed it to the screen. All right, and just a quick little note here, you can declare and initialize variables on the same line. So like I can do this, for example, int year equals 2020. This is perfectly fine. You'll see it done like this all the time. So it doesn't have to be on separate lines. It can be on the same line. That's perfectly fine. All right. Also note, we can manipulate data in different ways. There's built-in functions we can do called operators. So we can do year equals year plus 20. So let's say we were to do this. So again, we can see here assignment operating. So we're saying, okay, go to year, and we're going to assign it a new value. And this new value is going to be the previous value of year, and then plus 20. So here, plus 20 is kind of a default in the Java language. It knows what you mean, because we know year is an integer. So when you're saying plus, you're saying add. You know, we do 1 plus 1. We know that's 2. We don't have to think about it, that kind of thing. So when you do year plus 20, year is an integer, so we're doing 2020 plus 20. So if we were to save this and run this now, we'll see we'll get 2040. All right, perfect. So let's say we wanted to create our first Hello World program. This is what a lot of people do as their first program because it's really simple and it's really neat, that kind of thing. It's kind of like a, hey, I just learned how to program kind of thing. So this is actually really easy. So we can, so hello world, if we think about it, hello world is just a sequence of characters. We're saying H, E, L, L, O, you know, that kind of thing. So it's a sequence of characters. And we've already identified that a sequence of characters is called a string. That's called a string type. So we're going to create a string, and we're going to call this hello. And then we're going to assign this a value. We can just do this right away. And we're going to say hello world. World. All right, and then that's fine. Perfect. So we declared a string and we set it to this value. And like I said in the PowerPoint, we need to make sure we use double quotes for strings so that the JVM knows we're talking about a string. All right, then we can do the same thing we were doing before. So we can do system.out.print f, or we can do just print if you wanted to. We'll just do print here. We can do print and we'll just put in hello. Perfect. So when we called print here, we didn't do printf, so we didn't do any formatting or anything like that. We're just saying, go to the system, go to the console, output hello, output the value of hello. Well, hello has the value hello world. So if we were to save this and run this, we get hello world, and then that's it. So I hope this lesson was informative. We went over quite a bit of things. We learned, the basics of variables. We learned the basics of data types, that kind of thing, and we learned how to call a function, and we kind of got a feel for the basic syntax of Java. So if you would like to learn more about Java, check out our sessions at routefabric.com. Thank you.